All right, so in problem 7, we got to find the derivative. And what we're going to do is use a power rule to find the derivative of x to the fifth. And to find the derivative of 5 to the x, we just use the logarithmic property. So this will be equal to 5x to the fourth minus the natural log of 5 times 5 to the x. 5x to the fourth. And so the answer will be Q. So I would just advise you to memorize the derivatives of exponentials. It'll be a lot easier. All right, for 8, we got to find the limit as x goes to infinity of this expression. So the issue is that if you were to plug in infinity for x in the numerator and denominator, you're going to basically get infinity over infinity. You'll get like 10 minus like infinity over 5 plus like infinity. So you get basically and we say an indiscriminate value, like a value that's not very like clear on what it actually is going to be. So when you got something like this, when you have like 0 over 0, infinity over infinity, you want to use L'Hopital's rule, or it's spelled L'Hopital's, the L'Hopital's rule. And that basically says that you can just take the derivative of the numerator over the derivative of the denominator, and then try to plug in the value for x again. So what we do is we take the derivative of the top, that'll be negative 12x, over the derivative of the denominator, and that'll be 3e to the x. If we plug in infinity again, we're still going to get infinity over infinity. We're still going to get an indeterminate form. So we basically can just do it again. We just take the derivative again. So we'll get negative 12 over 3e to the x. And then here, you can see that if you were plugging infinity into x, in the denominator, you'll get like negative 12 over infinity. So this basically approaches a very, very small number. This basically gets infinitely close to 0. And so the answer will be B. And number 9, we got to find the region R that's bounded by the graphs y equals 2x and y equals 4x minus x squared. So let's draw a sketch of what's going on here. We have the linear graph y equals 2x, so that'll look something like this. And the quadratic, this will be a parabola. This is going to be downward facing. It's going to be doing this sort of thing. It's going to go through 0, 0. And it's going to intersect here at 2, 4. You can always solve for where they're going to intersect. 2x equal to 4x minus x squared. You'd then get 0 equals 2x minus x squared. X squared equals 2x. X equals 2. Now, on your exam, they're going to make the numbers very easy to work with. You're not going to have to worry about them being like decimals or fractions. Make sure you just are familiar with your basic graphs of exponentials, quadratics, so you don't spend too much time having to graph it or figure out what it looks like. But again, usually they're going to make the numbers and functions very easy to work with. Anyways, the region bounded is going to be here. This will be our region R. So we're going to write our area of R as the integral from 0 to 2, and the top function, which is the parabola, 4x minus x minus the bottom function, which will be 2x. Top minus bottom. Remember, you want to do top minus bottom because you're going to basically look at it like a rectangle, and you would subtract the rectangle below. The big rectangle will be from here. From there, you would subtract the lower rectangle. But don't overthink it, just the top minus the bottom. The top area minus the bottom area. So we just then integrate this, but let's simplify it first a little further. So this will just be 2x minus x squared dx. Then from here, we integrate, we get 2x to the third over 3. Or no, sorry, 2x squared over 2. Those 2 cancel. Minus x to the third over 3. And we're going to integrate from 0 to 2. So we're going to have simply x squared minus 1/3 x cubed from 0 to 2. Then we just plug in 2 first. So we'll get 4 minus 1/3 times 2 cubed, or 1/3 times 8. Plug in 0, and it's just going to be taken away 0. So 4 minus 8/3. So that'll just be 12/3 minus 8/3. So you'll just get 4/3. And so your answer will be B. Right, number 10. So here we're given the graph of f. And you're given that g is equal to x squared plus 1 over f of x. We have to find g prime of 2. So we're going to basically use the quotient rule to express what g prime of x will be. Then we just plug in 2 for x. So using the quotient rule, g prime of x will be the bottom function squared. So we're going to have f of x, the second power in the denominator. And on top, you're going to have the derivative of the top function, 2x, times the bottom function, times f of x, minus the top function, x squared plus 1, times the derivative of the bottom function, so times f. Now we're trying to find g prime of 2. So what we're going to have is plug in 2 for x. So we're going to have 2 times f of 2 minus 2 squared plus 1, which will just be 5. Prime of 2 f of 2 squared. Now it's 2 times 2, 4. F of 2, we look at our graph here. F of 2 will be 3 because we got the point 2, 3. So we're going to have 4 times 3 minus 5. Now f prime of 2 is the slope of this line at 2. The slope of this line, since it's linear, it's going to have a constant slope of 4. It's always going up by 4 and over 1. So it'd be minus 5 times 4 here over f of 2 squared. F of 2 we found to be 3, so over 3 squared. And then we just keep on simplifying. So 12 minus 20, so negative 8 over 9. So the answer will be A. And 11. Okay, we're going to integrate. And this, we can just reduce it or factor out that x, because an x goes into everything. So this will be equivalent to x minus 1 over 1, because you can factor out an x, which is just x minus 1 dx. Then from here, we can just integrate. So it's simply x squared over 2 minus x from negative 1 to 1. We have 1/2 minus 1 minus a 1/2 plus 1. So you're going to get a negative 1/2 minus 3/2. You're going to get negative 2. So your answer will be A. At 12, we're given this table for selected values of f. We're told it's differentiable. We're told, like, what intervals must there be in number c such as f prime of c equals 2? Okay, so let's study what the rate of change across these intervals are. So here, x is going up by 4, 4, 4. It's going up by 4 each time. Here, y goes down by 8, and it goes up by 2, and it goes up by 8, and it goes down by 9. So we look at basically like the slopes, the 4 slopes that we got here. We have first negative 8 over 4. Then we have 2 over 4. Then we have 8 over 4. And then we have negative 9 over 4. If we simplify this, it'll be negative 2. That'll be 1/2. That'll be positive 2. And that'll be negative 9 over 4. Now, what this problem is getting at is the mean value theorem on the MVT, which is basically saying that if the slope across the endpoints, if f of b minus f of a over b minus a equals some number, whatever the number is, whatever this slope is, there must be a value of c between b and a such that you can find it that it'll equal the slope. So in this case, you're looking at f prime of c, and it's saying, where can you say that the derivative is 2? F prime, where is f prime of c equal to 2? And you just look to see where it changes it by at least 2. And it changes by 2 exactly in this interval where we got 8 over 4. So in this region here, when x goes from 8 to 12 and y goes from 2 to 10, it could very well, have steeper slope somewhere between, but it has to have at least somewhere a tangent line that's equal to 2, or that has a slope of 2 somewhere in there. That's just by the mean value theorem. So then the answer will be C. Okay, in 13, we want to find the limit as x goes to 0 of sine of x over e to the x minus 1. And so here, if you were to plug in 0 for x, you would get sine of 0 over e to the 0 minus 1. You would essentially get 0 over 0. And so when you have this is an indeterminate form, excuse me. So you want to use L'Hopital's rule. So L'Hopital's rule basically says that when this occurs, or when something, like this or this occurs, when you get some form that's not a clear number, then you just take the derivative of the top and you take the derivative of the bottom and let's see what happens. So the derivative of the sine of x will be the cosine of x. The derivative of e to the x minus 1 will just be e to the x. And now let's see what happens when you plug x equals 0 into there. You plug x equals 0, you'll get the cosine of 0 over e to the 0. Cosine of 0 is 1. E to the 0 is 1 as well. And so then you'll get 1. And so you get some clear number, some clear value. And so the answer will just be A. All right, number 14, we got a physics application. We're told that a particle moves along a straight line so that at time t is greater than or equal to 0, its acceleration is given by a of t is equal to 12t. at time t equals 0, the velocity of the particle is 2 and the position of the particle is 5. Which of the following is an expression for the position of the particle at time t is greater than or equal to 0? Okay, so one way that we can solve this is by integrating using the properties of integrals and understanding that the integral in this case of a of t, that will be just v of t, because v of t is the antiderivative of a of t, meaning that if you took the derivative of v of t, you would get a of t. Likewise, we can also find s of t by taking the antiderivative of v of t, basically evaluating the integral v of t dt. So let's go from what we're given. Let's call it a of t equals 12t. So this is the same as the integral of 12t dt. So from here, let's find the antiderivative of 12t dt. That'll be just 12t squared over 2 plus c1. So this is the same as 6t squared plus c1. I'm just calling it c1 because we're going to have another constant when we integrate v of t. So that's just to distinguish it. Now we can solve for c1 with the information that we're told that at time t equals 0, v of t is 2. Because remember, this is v of t. This is the equation for v of t. So v of 0 is 2. So when you plug 0 in for t, you're supposed to get 2. So that just means that c1 is 2. So that means your constant here is 2. So with that, you can go further and set up s of t as the integral of 6t squared plus 2 dt. And then we can integrate this. So s of t will be 6t to the third over 3 plus 2t plus t2. Now, likewise, this is just like 2. This is the same as 2t cubed. Now, we're also told that the position of the particle at time t equals 0 is 5. So s of 0 is 5. S of 0 is 5. So then we can basically solve this for t2 because we can set this equal to 5. So 5 would be equal to 2t cubed. 2 times 0 cubed plus 2 times 0 plus c2. I'm sure you can do this in your head. I just want to show it to you. Because that's 0, and that means that c2 then is 5. And then now you can write your expression for the position function as s of t is equal to 2t cubed plus 2t plus 5. So your answer will be D. All right, 15, we're given that f of x is defined as this piecewise function, and we want to figure out which of these is true. So it looks like each of these conditions are talking about whether the function is continuous and or differentiable. So let's first see if it's continuous. For it to be continuous, that means when you plug 5 into this expression, you're going to get the same y value, because that would mean they would connect. So let's see what happens when you plug in 5 in here. So if you plug in 5 into the top function, you would get negative 25 plus 5. You would get negative 22. And when you plug 5 into the bottom expression, you get negative 10 times 5 plus 28. So negative 50 plus 28. And so you would also get negative 22. So it's continuous. to connect when x is 5. So we know it's continuous. Now, let's see if it's differentiable. So let's first find the derivative of f of x. The derivative of this top expression would be negative 2x. And the derivative here would just be negative 10. Now, to find if it's differentiable at x equals 5, that means when you plug 5 into here and here, you would get the same value. Similar to this idea. So when x is 5, that's negative 2, the f prime of 5 here will be negative 2 times 5, you get negative 10. And here, this doesn't even have a variable. It says the derivative is always negative 10. So it's going to be the same as this. So then we can say that the function is both continuous and differentiable at x equals 5. So your answer will be A. So 16. We're given that dy dx equals 2 minus y, and if y equals 1, when x equals 1, then let's find y. Okay, so here we're basically gonna integrate. So we're gonna divide both. We're gonna multiply both sides by dx. I'll do it step by step in case you get a little confused. Now treat this like a fraction, and then we're gonna divide by the 2 minus y. So you're gonna have 1 over 2 minus y dy on the left is equal to dx on the right. And then we just integrate both of these. Integrating the left, we can find using the u substitution, or using basically it's going to be the natural log function. Now I'll work it through just in case you get confused by this. But if we make u equal to 2 minus y, then du will be negative dy. When we don't have negative dy, we just have dy. So we're going to have negative du equals dy on the left. So we're going to have negative 1 over u du is equal to the integral dx. So integrating this, we get negative times the natural log of the absolute value of u is equal to x plus some constant, c1. I'm going to work it out down here so that I don't have to squeeze it all in. And then here, let's just distribute this negative to the right side. So let's have the natural log of replacing the u with a 2 minus y is equal to negative x. Now let's just call that c1 a different constant so we don't have to like do minus it, or we'll just do plus c2, because multiplying by negative 1 would technically change to c1, so we call it c2. Now remember, this is an exponential, or a logarithm with base e. So we're going to write this as e to this is equal to the absolute value of 2 minus y. Now we don't need the absolute value symbol anymore because we're given this condition. So we know that they're both going to be, it's going to 2 minus 1 is going to be positive. We don't have, and you really never have to really worry about that on an exam. The only time you may have to explain it slightly is on a free response question. Just on a multiple choice, don't worry too much about having to track to see if you can take away the absolute value symbols. I've never seen a problem where you couldn't. Okay, so here now we just solved for our constant. Now this is going to be the same as e to the negative x times e to the c2, because you can just add them. And if e to the c2, we can just make it a. So this is just 2 minus y is equal to moving the a in front, a times e to the negative x. And let's solve for that a. We're told that when x is 1, y is 1. So let's plug in the point 1, 1. So 2 minus 1 is 1, equal to a e to the negative 1. So then dividing by e to the negative 1 is equal to a, and that's the same as e. So then your a is just going to be equal to e. Your a is equal to e, and let's go rewrite this way up here so we can go back. So then we can have that 2 minus y is equal to e times e to the negative x. This would be the same as 2 minus y equals e to the negative x plus 1, just by the exponent property. And then when we solve for y, let's take away this 2 and divide by negative 1. So then y will be e to the negative x plus 1 minus the 2 divided by negative 1. And so we can write it completely as y will be equal to negative e to the negative x plus 1 plus 2. Let's see which of these. Won't be that one. It'll be B. Yeah, this is just a different form. They just move. It's just in a different form or a different order. The 2 or they put it in front, and the x they switch it. Your answer will be B. All right, let's look at 17 now. We're given that g is the function given by this integral. Now, when you have this, and you have no like complications, you have like no like you don't have like x being multiplied or raised by a power. It's just x. You can use the second fundamental theorem of calculus to find that, or in this case, you can just take the derivative actually, because we want to find the x coordinate of the inflection point. So we got to find the second derivative. So we first find the g prime of x. When you differentiate an integral, this just cancels out, and this just becomes x squared minus 5x minus 14. Recall that the t is just there as a dummy variable. It represents x values just as usual. And then we keep on going and take the derivative again. And we'll get 2x minus 5. And we find an inflection point by finding where the second derivative is equal to 0. So g double prime of x is equal to 0. So 0 is equal to 2x minus 5. Add 5 and get 2x. Then x will be 5/2. Now, you can go further and check that the concavity changes, but in this case, you don't even have to go any further because it only gives you one possible answer of 5/2. So then we know it's going to be B. So use that just as like just using the benefits of a multiple choice test as logic. All right, so in problem 18, we're going to take the derivative of x cubed times the secant of 2x. So this is going to involve using the product rule and the chain rule. So we have our two functions that we're multiplying by one another, sort of. We have three functions, but what we're going to do first, take the derivative of x cubed, 2 squared, leave secant of 2x just as it is. And then we're going to add x cubed we leave that function the way it is, multiplied by the derivative of the secant of 2x. So the derivative of the secant of 2x will be the secant of 2x times the tangent of 2x multiplied by the derivative of 2x, so it'll just be 2. And then from here, we just simplified it. This will just, there's really not much we can't really combine this. It'll just be 3x squared secant of 2x plus 2x cubed secant of 2x tangent of 2x. Yeah, I think that'll be, yeah, the answer will be D. Number 19, we're told that a particle moves along the y-axis so that at time t is greater than or equal to 0, its position is given by y of t equals t cubed minus 4t squared plus 4t plus 3. And which of these statements describes the motion of the particle at time t equal 1? So it looks like we're looking at the velocity, and when it's saying how the velocity is changing, if it's increasing or decreasing, we're talking about the acceleration. So we're going to study what the first derivative is and the second derivative is. First derivative is going to describe the velocity. Second derivative is going to describe the acceleration, or how the velocity is changing. So we take y prime of t, that'll be 3t squared minus 8t plus 4. And then the second derivative of y will be 6t minus 8. And then we see what's going on when t is 1. So we take y prime of 1, which will be 3 times 1 minus 8 times 1 plus 4. So 3 minus 8, negative 5, plus 4 will be negative 1. Then y double prime of, we'll take y double prime of 1, which will be 6 times 1 minus 8, which will be negative 2. So since the y prime of 1 is negative, that's basically saying that the velocity is negative. Now, when we're talking about velocity, the direction basically describes, the sign basically describes the direction. So if velocity is positive, then it's moving in the positive direction. If velocity is negative, it's going to move in the negative direction. The number, the value, like in this case 1, describes like the magnitude, describes like the speed. So in this case, since we're talking about a particle that's moving up and down the y-axis, this is saying that the particle is moving down the y-axis. So we know it's not going to be C or D. Moving down the y-axis. And the second derivative is negative 2. So it's saying that the velocity is decreasing. So then the answer will be A. And 20. So this one is asking what do these can't be determined. So we're given the integral of x from 1 to 4 and the integral of g of x from 1 to 4. So let's just go ahead and see if we can evaluate any of them. So the integral from 4 to 1 of g of x, that would just be the negative value of this one. So instead of negative 2, it'll be positive 2. So we know the answer is not A because we can figure that out. The integral from 1 to 4 of 3 times f of x, given that f of x is 8, so this will just be 3 times 8. So this will be 24. So we can figure that one out. C, we're given, or we're asked to find the integral of 3 times f of x times g of x. This one you can't figure out because you can't simply multiply integrals like this. This is not a property of them. So the answer will be C. (21) For any real number x, we're given the limit as h approaches 0 of the sign of 2 times x plus h minus the sign of 2x over h is. Okay, so don't get lost and try to, fall down a rabbit hole trying to do algebra. This is really just a problem where they want to assess if you can identify that this is the expression for the derivative. So this is simply the derivative of the sine of 2x. That's what you want to find. Remember, if you remember when you first learned about derivatives, you learn about the limit as the distance between 2 points going to 0, and you found the slope of the secant line, that sort of thing. This is that same expression, essentially. So we're just finding the derivative of the sine of 2x, and we can just use our chain rule and the fact that we know what the derivatives are. This will be the derivative of 2x, which is 2, times the derivative of the sine of 2x, so it'll just be the cosine of 2x. The answer will be D. All right, 22. You're given the slope field. You want to figure out which of these derivatives match the slope field. So the slope field is essentially what it sounds like. It's basically a graph of slopes. And the slopes are just the dy dx's at specific values of x and y. So at points. So like here we have the slope at 0, 1. Here we have the slope. Here we have the slope at 0, 1 half, 0, 1. Looks like 0 and 3 halves, 0, 2. That sort of thing. So you want to see which of these equations will give you the slope here. Now, there's not really, again, a formula where you can just straight up figure it out. Really kind of want to analyze and use process of elimination. The best way, if you don't want to stress out about it, is just to plug and chug. But it could take some more time. So again, just think it through. But you can always test, and there's always going to be one that's only going to work. So what I advise is to kind of just figure out the pattern of the slopes first. So if you look on this side of the x-axis, the slopes are positive. Over here, the slopes are positive again. So it looks like the slopes are always positive. They get more flat, they get closer to 0 as they get towards the x-axis. The other thing that you can notice is that all the slopes are parallel for any given value of y. That means that it doesn't matter what the x value is. It only matters what the y value is. So you can actually eliminate this and that. And you can just then check. But this one, remember, if you cube a negative number, you would get a negative slope. So it can't be this one because you always have positive slopes. So the answer is going to be D. And again, that's just kind of my logical reasoning way. You can always just plug in numbers for x and y in each of these and test some points, and you could always do it that way. But this is kind of the analytical way I would go about it. 23. The base of a solid is the region in the first quadrant bounded by the y-axis, the x-axis, the graph of y equals e to the x, and the vertical line x equals 1. For this solid, each cross-section perpendicular to the x-axis is square. What's the volume of the solid? Okay, so let's draw a sketch of what this would look like. Whoa. If I can get my pencil to work. Make sure you know your graph of your exponential. So that would just be something like this, y equals e to the x. 1 through 0, 1. And it's bounded by the vertical line x equals 1. So this represents the base. Now, it's saying that each cross-section perpendicular to the x-axis is square. So the cross-sections are essentially, let me kind of see if I can draw an idea. These would be like cross-sections, these vertical rectangles. Now, this will be the direction of it. So let me try to draw like a 3D picture so you can kind of see what's going on here. I'll do my best to see if I can do it. So here, looking at an angle, different perspective, x, y. Could be the line dy equals e to the x. So this would be like the z-axis. When you get to three-dimensional calculus, you'll be dealing with, you know, three spatial dimensions. So x, y, and z. And so what they're talking about are cross sections, if you can remember, and we're going up to a line x equals 1. It would be like, let me see if I can grab a different one. It would basically be something like this. This would be the base, and then it would pop up like this. And then over here would be another one. This one would be slightly bigger. And over here would be the biggest one. So you're getting basically this sort of like rectangular prism thing, shooting off like this in 3 dimensions. Now, so you have, since these are squares, this side will be the same as this side. Now, this side is this side right here. So the length of this from here to here is basically the e to the x. This will just be e to the x. So cross section to the side here, one side would just be e to the x, but since it's square, this would be e to the x as well. So if you want to integrate a cross section, what you want to do is basically find a formula for the area of each cross section. Since this is a square, the area of each cross section is just e to the x times e to the x, or just e to the x squared, or e to the 2x in other words. And then so then we set up our integral from 0 to 1 of e to the 2x dx, and then we integrate this. And that'll be e to the 2x over 2 from 0 to 1. That'll be e to the 2 over 2 minus e to the 0 over 2, which will just be e to the 2 over 2 minus 1/2. Pardon my messy handwriting. And then that'll be, your answer will be 24. The graph of the piecewise linear function is shown above. What is the value of the integral from 0 to 12 of f prime of x dx? So if you can remember the proper, like how the concept of integrals, when you evaluate an integral, you're basically finding the antiderivative of whatever expression is in here. So you want to find the expression whose derivative is f prime of x. And that's easy because that's just, trivial. That's just going to be f of x. So we're going to evaluate f of x at 0 and 12 using the first fundamental theorem of calculus. So we're going to have f of 12 minus f of 0. And we're given the graph of f. So f of 12 is negative 4. And f of 0 is 4. So we have negative 4 minus 4, which will be negative 8. So our answer will be A. All right, so in 25, we have that the equation for y is equal to 2 e to 6x minus 5, and we're told that it's a particular solution which is the following differential equation. So essentially, you just want to figure out which of these equations this will satisfy. So let's start off by taking the derivative and second derivative. That way we can just plug it in easily. So let's find y prime. This will be equal to 6 times that whole thing. So 12 e to the 6x. And then y double prime will be, again, we take the derivative of 6x times it by 12. So 72 e to the 6x. And then let's just check them one by one. Usually it won't be too tedious because obviously we don't have a calculator. So let's start off with the first one. So we have 12e to 6x minus 6 times y. So 6 times 2e to 6x minus 5 minus 30 equals 0. So we want to see if this will be true. So 12e to the 6x minus 12e to the 6x plus 30 minus 30 equals 0. And what do you know? Right away, we get 0 equals 0. So then the answer will be A. So we found it on the first shot. 26. What is the value of x at which the minimum value of y equals 3x to the 4/3 minus 2x occurs on the closed interval? So we just have to find the derivative and then find the critical value on this interval and then compare that if we find any critical values between 0 and 1. So let's find the derivative. Y prime will be 4/3 times 3 x to the 1/3 minus 2, or just 4x to the 1/3 minus 2. We set the derivative equal to 0. So you get 0 equals 4x to the 1/3 minus 2. 2 equals 4x to the 1/3. Divide by 4. We'll get 1/2 equals x to the 1/3. So remember, from algebra or pre-cal maybe, you're going to cube both of these to undo the 1/3 root. So we have 1/3 or 1/2 to the 3rd power, and this to the 3rd power as well, and then we'll get 1/8 equals x. And then we can see what well, kind of already given the answer. But let's just see if it compares with 0 and 1. So what you can do is just plug in, evaluate the function at 0 and at 1 and at 1/8, or see if the derivative is decreasing before 1/8 and then increasing after 1/8. Or you can also just or you could see what the second derivative is here. You can see what if the second derivative at 1/8 is concave up. But so there's a couple different ways to do it. So let's just compare. Let's just compare y of 0 with y of 1/8 with y of 1. So y of 0 will be 0. Y of 1 will be 3 times 1 minus 2 will be -1. Y of 1/8 will be 3 times 1/8 to the 4/3 minus 2/8. So 3 times 1/8 of 1/3. So that'll be 3 times the 3rd root of 1/8. So it'll be 1/2 to the 4th. And minus 1/4. And we'll get 3, go down here. 3 over 4, 2 to the 4th, 2, 4, 8, 16. So 3/16 minus 1/4. So that'll be like negative. This is 4/16, so negative 1/16. And I actually made a mistake here. This is actually +1. My bad. That would have made our lives a lot easier because both these are positive. This is negative. So then we know the minimum value occurs at 1/8. And again, on a test, it's usually going to be pretty obvious, or maybe not obvious, but like they usually want to test like one concept to see if you know how to find the critical value. So you usually may not have to waste time with having to evaluate each one. But it's good just to double check. It's 27. All right, time t equals 0, a storage tank is empty and begins filling with water. For t is greater than 0 hours, the depth of the water in the tank is increasing at a rate of W t feet per hour. So the following is the best interpretation of the statement. Capital W prime of 2 is greater than 3. Okay, so this one is kind of meant to trick you or to really test your maybe reading comprehension and calculus understanding. But it's already telling you that W or capital W of t is describing the rate at which the depth of water is increasing. So you're already told this is a rate. So then if you take the derivative of this, then you basically are describing the rate of a rate. So you're not just basically just like going to say it once or think of it like as, you know, the level of the water, the level of the water changing, but you're trying to basically look at like the level of how the rate of the level is changing. So you basically want to look for something that says the rate of the depth of water per. Now that's the tough part. The 2 just means, you know, 2 hours later. That's 2 hours. 2 hours later, the rate of the rate is greater than 3. So 2 hours after the launch, the depth of water is increasing. It's not going to be this one. It's only saying it once. It's not saying rate of rate or the rate of the depth. You want to look for the rate of the depth. Over the first 2 hours, the depth of the water is always increasing. Great. It's not going to be that one. 2 hours after the tank begins filling. And it's definitely not this one because this is over the first 2 hours. It's not going to be over. It's going to be at 2 hours. 2 hours after the tank begins filling with water, the rate at which the depth of the water is rising is increasing at a rate greater than 3 feet per hour per hour. So the answer will be C. And again, the difference between why it's C and not D is because this is over the first 2 hours. It's not over the first 2 hours. It's basically at 2 hours later. Here's 28. So we have a person stands 30 feet from point P and watches a balloon rise vertically from the point as shown in the figure above. The balloon is rising at a constant rate of 2 feet per second. What is the rate of change in radians per second of angle theta at the instant when the balloon is 40 feet above point? Okay, so let's make it clear what we want to find. We want to find d theta dt, the rate of the change of the angle. So it's finding a way to express like this relationship. So we'll use a tangent function because remember this is going to be, we'll call this our y. We're told that the balloon is rising at a constant rate of 2 feet per second. So dy dt is equal to 2 feet per second. So we're talking about this angle. We can say that the tangent of that angle, theta, is equal to the opposite over the adjacent, so equal to y over 30. You don't have to make the base of this x because the 30 is constant. It's not varying, so you can just leave it as 30. You don't have to don't put y over x. So tangent of theta equals y over 30. And then we take the derivative of this with respect to theta, or with respect to time. So we take d theta dt multiplied by the derivative of the tangent function, which will be the secant of theta all to the second power, or the secant squared of theta. And that'll be equal to 1/30th times the derivative of y, which is just 1, so we don't have to rewrite it, times dy dt. Now the rest is honestly just like trig. So we're given dy dt, So let's rewrite this as d theta over dt equals dy dt is, remember, 2. So we can put this as 2/30 over, we're going to divide both sides by the secant squared of theta. And we want to evaluate this. Now, remember the secant of theta is just 1 over the cosine of theta. So then this will be the same as 2/30 over 1 over the cosine of theta. And you flip this would be the same as 2/30 or 1/15 times the cosine of theta, or the cosine squared of theta. And now let's just find what the cosine of theta would be. Now, remember the cosine of an angle theta is equal to the adjacent over the hypotenuse. The adjacent side is 30. The hypotenuse would be this, since this is a right triangle. And what you can realize is that we're evaluating for when y equals 40. So what you have here is really a 3, 4, 5 triangle, or 30, 40, 50. And you can solve for it if you want. You can do 30 squared plus 40 squared, and you'll find that 30 squared plus 40 squared equals 50 squared. So the cosine of theta will be 30 over 50. So what you have here then is just 1/15 times 30 over 50 squared. And then let's see, so here we can simplify that. That'll be, we can reduce this, 30 times 30, no calculator here, so 30 times 30 times 50 times 50. So 30 over 15, that'll just be 2. Then you have 30 over 50 times 50. So then you have just 60 over 50 times 50, 60 over 2,500. Or 6 over 250. Which would be 1 over 125. No, it's really not 1 over 3 over 125. Whew. Luckily, there's no 1 over 125. There's a 3 over 325. So the answer is B. All right, and then number 29. How many vertical asymptotes is the graph of y equals x minus 2 over x to the 4th minus 16/2? So what we're going to do is factor this down. We're going to have y equals x minus 2. You can factor the denominator into x squared minus 4 times x squared plus 4. Furthermore, that factors in the x minus 2 over x minus 2 times x plus 2 over x squared plus 4. So these x minus 2's cancel, and you really just have 1 over this. And remember, asymptotes you can find them where the denominator will be undefined. So you would basically look for x plus 2 is equal to 0. So you would have an asymptote of x equals -2. This, you can't make x squared plus 4 equal to 0, at least in the real numbers, because x squared plus 4 will lead to x squared being a negative number, which can't occur in the real numbers. Now, you're only going to have one asymptote because what happens here is that you remove this. So you basically have a point of, you have a removal discontinuity. So you're actually going to have an asymptote at x equals 2. So you're only going to have one asymptote. So make sure you remember that. The last one, 30. What value of b does the integral from 1 to b of x squared dx equal the limit of this whole guy? Okay, so let's write this out. So we have the integral of 1 over 1 to 1 of x squared from 1 to b. So we have the equation y equals x squared. We're going from 1 to b. We want to figure out what b would be, essentially. We have this area here. Now remember, this is a Riemann sum. And what you want to do is figure out what this matches, what endpoint this would correspond to when you were first doing Riemann sums. You remember in Riemann sums you had something like, you know, either maybe in your book was m sub I or x sub I, but you basically had something like the f of x sub I times delta x. Sometimes in the book maybe you had m sub I or like large m sub I, maybe something like this, like lower sum or upper sum. That part is not too big. That's not too important exactly what notation your textbook may have used. But you want to understand this is going to be the height, and this is the width of each rectangle. So remember, you're making rectangles, and you want to find like if 2 over n is the width, if you remember the width of each of the ith rectangle, we would use delta x. You'd basically take the total length from A to B and divide it by n, so b minus a over n. We could have, in this case, we know a is 1, so we have b minus 1 over n. Now, if b minus 1 has to be 2, that means b has to be 3. So we're evaluating from 1 to 3. So your answer is going to be 3. That's one quick way to kind of check that. You can get more elaborate and more detailed by recognizing that this will be like the one of the endpoints where you have a plus I times delta x. And again, you're going to have that a is the 1, if you know is over there, plus I, the delta x, will be the b minus a or the b minus 1, and you'll get 2 again. So in either case, it'll still work out the same. So your answer will be B.